So you are familiar with different network algorithms. What we're going to look at this morning is...
In this lesson on modelling with networks, these students are being asked to apply their knowledge of network algorithms to think about how they would solve problems in real-world situations.
Can anyone tell me what you're looking at here?
A map of the London Underground.
A map of the London Underground, good, okay. And what we're looking at this time? What I wanted them to get from the activity is that we are taking the ideas that they've met in Discrete maths and using them to model real-world situations. So something like a tube map is an image they'll all be familiar with. Which of those two representations of the Underground is more effective?
The bottom right, it's easier to visualise
than
the actual layout.
So the top left-hand one, we had the actual layout showing the actual streets of London, what it would look like, but it's quite jumbled, it's quite messy. So we've got here a simplified version designed by a guy called Harry Beck, showing them that and making them think, well, hang on, why do we use this version, not a more true-to-life map-style version? Is just an extra step in helping them appreciate the value of these sorts of methods in terms of simplifying problems down and really focusing on the key detail and the key information. Which algorithm do you think might be useful for this sort of problem?
Probably like Prims or Kruskalls.
Prims or Kruskalls. What about if you were in charge of gritting the roads before winter? What might we want to do first with a problem like this?
Working in pairs, they are to decide for each scenario on the cards what kind of algorithm they would choose to help solve the problem, and justify their choice in each case.
Okay, should we start with the snowplow? Because that's what I understand.
Yeah, snowplow. So which one was that? That was
the Chinese one, wasn't it? So that's route inspection.
Yeah.
The Highways Authority has to go to every road.
What I find when I've taught network algorithms in the past is that students very quickly become quite adept at taking the different algorithm and applying it to a given situation. What they sometimes struggle with is knowing which algorithm is most applicable in which case. So what I wanted from this discussion activity was for students to really get to the nitty-gritty of what these algorithms do, when they might be appropriate, and why sometimes one might be more appropriate than another, or maybe situations even where more than one was appropriate depending on the situation given. Milk tanker collecting milk from several different farms. So if you imagine that sort of journey, what would you want to try to avoid happening?
Going same route twice, maybe.
Yeah, you want to sort of avoid going back. Where did you have it first of all? What was your original go? Yeah. Why do you think that would end?
Because you don't have to go along every road, you just have to go to certain places. So that does seem like the obvious one.
Okay, so that one rather than that one if it was each road. Good. Excellent. I'll leave you to finish off the others.
We're not quite sure what it means because there's so many different things that it could be. The flights crossing over. Does it mean that
it's dealing with things crossing over, and none of those algorithms really deal with paths that cross.
Okay. The idea of having the card activity, it helps me as a teacher to work out where their problems are. The fact that it's cards, it means that they're talking about them more. So some of them will have perhaps a better understanding of one algorithm than another, and they can benefit from each other's confidence.
I think a minimum spanning tree doesn't cross over. And if you think about it, if it's coming from like an airport or a few airports to different places.
But the thing with that is you're dealing with more than just linking the places together quickly, because you're looking at whether they cross.
There was time for them to work together and discuss their thoughts. What I did towards the end of the lesson was to ask them to identify the ones that had caused them the most problems, so that we could then discuss those as a whole class.
Coordinating flight paths between a number of cities so that the flight paths don't cross over.
Any other pair like to say where they put that one and perhaps justify their decision?
We put it in the route inspection one. You don't need to go on any of the roads twice, so you don't want any paths to cross over.
We put on a minimum spanning tree. You want them all to be connected, but you don't really want them to cross over, so you didn't think you really want to go back on yourself at all.
It's a nice touch that some of those problems didn't fit any of the 4 categories that the students had on the table in front of them, but you didn't tell them up front that there might be some problems that were outside.
When you're doing this sort of activity with little cards and matching things up, sometimes the solutions can be too convenient. I think it's important when you're looking at modelling not to make everything too neat, because modelling is all about adapting the real world, and the real world isn't neat.
We had the opportunity to sort of talk together about it, and so having someone else to sort of reinforce a lot of your thinking was really good.
Before we'd only looked at the individual examples like Chinese place problem, but when you had all 4 of them together, it was kind of harder to tell which ones were which, and then like Amelia was saying, you could explain your reasoning and then talk to your partner about it and come together to make a joint decision, which was quite helpful, I think.
the sorts of things that I really enjoyed picking up on, where there were discussions where I could see that students had changed their mind because of what their partner was saying. So it was listening to where they had the most debate, the most discussion and contrasting opinions, because I think that highlighted to me that's the sort of thing that if we don't have this time to reflect on, they might leave the room with those misconceptions and might then come unstuck later on.